Hi everyone, and welcome with part 3 of the Wazuh training. In this section we will cover Wazuh decoders and their rules and the reasons behind them. The first topic is decoders, and we will look at their purpose, what they provide you, what their outputs look like, etc., and how they tie in with rules, what rules are, what their purpose is, and the output that they provide you as well. For custom rule creation, etc., there is ample documentation on the Wazuh website that you can review at the URL at the bottom of this slide. When it comes to decoder considerations, the important things to look at is event analysis. So if you are ingesting a new type of log that you haven't before ingested, or there are no decoders or rules for it, it is important to look at the data to see what is valuable and what is not valuable. This is the primary driving force behind creating new decoders, rules, etc. It doesn't help spending hours or even days on creating decoders for events that provide no benefit. You could have switches that tell you that they forwarded traffic from one port to another, but there may not be a source or destination IP necessarily, and that would not really help you unless you have additional information to support such information. To say, for example, port 14 is one specific VLAN and port 15 is another, and you saw traffic for SMB jump across those ports, which shouldn't be allowed, for example, if you have ACLs in place, etc. The decoders and the rules are all consisting of a structure of regex. The decoders are a little bit lower layer regex because there are limited options that you can apply to creating new decoders, and the reason for this is because the function of the coder is to strip out the attributes that you need to look at. In Wazuh's context, those are referred to as fields, and the default attributes that they support is user, source IP, destination IP, source port, destination port, protocol, action, ID, URL, data, extra data, status, and system name. Those are called traditional or original fields in Wazuh. Since later versions of Wazuh, it has been allowed to create additional fields. They are named dynamic fields, and by default those are limited to 64 fields in total. So if you extract more than 64 fields, the system will generate an issue, but you can very easily compensate for that by increasing the analysis decoder order size in the internal options.conf file. So how to build decoders? As stated, you need to look at the event analysis. If you look at the example provided, this is the standard DHCP discover, request, offer, and ACK on a DHCPD service. The version doesn't matter at this point in time. So what you would look at here is, number one, the action taken. Is it DHCP discover, DHCP request, DHCP offer, or DHCP ACK? Then you would look at items like the MAC address, the DHCP relay that passed the request on, or the gateway that passed it on, and the host names, etc., etc., etc. So you would classify the information that you would need out of the events by looking at them. You would try to discard any unnecessary information, like you wouldn't necessarily want to classify via as a attribute because it doesn't give you any value, so that one will be excluded. And such items. You will find that with more complex log sources, like for example a UTM based firewall or AV products, etc., those log files or events can become quite verbose, and you don't necessarily need all of that. You essentially may need in the case of AV, you may need just what was found, where it was found, and which machine it was found on, and what time and date, which is by default ingested anyway. So you would look at the structure, you would classify which fields you want to extract, what what fields are just noise or doesn't matter to your extraction, and you would then classify your attributes. So by default, what you would do is you would try and classify your attributes to the default attributes or field names that is standard within Wazuh. This is especially important for your DST IP, your SRC IP, for your destination and source IPs, etc., because there are other rules and components into the system that can come into play at a later stage should you choose to use them when it comes to the rule structures, etc. But those work best if you stick to the standards. Any fields that you want to classify as an attribute or field, and they do not conform to any of these descriptions, you are more than welcome to create your own. If you had an additional field in here that had a description for the VLAN, for example, and that's logged with the event log, you could extract that and say description field, for example. That is all allowed. For the decoders, you will need to have some regex knowledge, etc. As demonstrated on the previous slide, here you can find all the syntax and the regex qualifiers and quantifiers that you may need. For the rule considerations, you need to define the criteria for the alert. You need to specify what it is that you're looking for, and then you need to specify the description for it. The description is very important. If you have a description that's just 1, 2, 3, 4, 5, 6, nobody's going to understand what it is that you're trying to tell them. Imagine that you're trying to tell them a story, and this is a very compact and condensed way of telling them that story. It can be one single line, it can consist of variables, and you can then tell them in a single line, this is what's happened, and you can assign an alert ID to it. So that's where the alert level or classification comes in. This is actually quite important. There are two approaches when it comes to Wazuh and alert levels or alert IDs. The default documented approach for this on the Wazuh website is an ID. It doesn't necessarily indicate severity, although it can be attributed to a degree. It is more a case of an action taken. If we were to go to that URL and look at the classifications, you can see that it starts at 0 and it goes up to 15. Each one of them has a title and a description that is documented as part of Wazuh. These do not really change, and they are guidelines if you choose to use this approach. It does not prevent you from using your own alerting values and structures, etc. So something important to bear in mind is Wazuh will not permanently log anything that is below a level 3. Anything below a level 3 will be discarded. So if you have noisy events that happen to come along after you've constructed your decoder and your rules, you are more than welcome to add an additional rule that will rewrite that specific event based on your specific criteria, and that will then discard that data so that it doesn't unnecessarily clog up your system with useless or unnecessary data. There are various Windows events, for example, that do not indicate anything sensitive, and you can decide based on your environment and your compliance requirements to either reclassify those from, say, a level 3 to a level 2 or a 0, or you can even increase them if you like. By default, most of your categorizations will be 3 for successful authorized events, system low priority errors, user generated errors, those are usually your login failures, etc. Then your low relevance attack. So these are usually when you've got attack specific criteria that you've classified in your rules. Bad word matching is it will look for specific words inside the alerts, etc. So it all depends on the type of logs that you're ingesting. First time seen is rarely used. This is used in cases where you want to be alerted whenever something happens for the first time. So it is very important, but not worthy of, say, for example, a level 12 and up alert. So it's just something that you would like to be aware of to inform you. These should not be noisy. If you are creating alerts and you're seeing 1,000 of them per day, then you need to choose a different classification, because then it's the standard and not something to be highlighted. Unless, of course, it is something to be highlighted, but you're only picking it up now that you've created the rules, which has been prone to happen as well. The areas that you really want to focus on is 11 and up. So multiple user generated errors. So for example, if you have a proxy server that is AD integrated and somebody has stored a AD password somewhere in a browser or a tool, you can get thousands of alerts based on the tool retrying a connection to a website after a user's password has expired or something similar to that. So what you're looking for is 11 and up. It's your integrity checking warning. So this is if sensitive files are being modified. That shouldn't be. It can also be for IDS attacks, etc. For successful attacks that's measured. And your high importance. These are items such as, a perfect example is in my testing I saw today that I exceeded the queuing threshold on one of my agents, which could potentially lead to event loss. So that indicated that I needed to adjust the configuration on the agent to allow for a larger volume of logs to be shipped at once. Those items are usually items that require an action relatively soon or as fast as possible. 13, 14, and 15 are very severe. If you get these level of alerts, it means immediate jump to action, all hands on deck, and requires immediate attention. With this in mind, we'll quickly jump into starting building a decoder. So some of the options available to you when it comes to creating the decoder is pre-classified conditionals as such. So on the Wazuh website, once again, you will find that there are various options that comes into the creation of a decoder, and it is quite important to give this a read through at least once, because it will give you guidance on what component would be best to use for something specific. Like for example, decoder types, etc. And they will give you examples on how to build these and what the structure should be. All of these, even though they're regex based, are encapsulated within XML, which tells the system exactly how to structure the approach to actually extracting the valued data that you're looking to extract for alert generation, etc. There are numerous items listed here. And it will give you options that you can look at, and you can even see that it's got links to additional information for specific categorizations, etc. And you can go through that. Here is an example of the regex, for example. Now, I know what you're going to think. If you're not comfortable with regex already, you're going to look at that and say, that does not make any sense. By the time we're done with this session, you will be a little bit more comfortable approaching the events for analysis and correlation. It is very logical, even though it may not seem that way. So when it comes to regex, you can look at the regular expressions. If you look at the fields here, you will see that there are parentheses, and then there's backslashes with a character next to it. And then after the character, there is usually a plus or an asterisk. Plus means 0 or more times. Asterisk means 1 or more times. So I had that reversed. Plus is 1 or more times, and asterisk is 0 or more times. So this is basically what you're looking at. A backslash with a lowercase w will give you pretty much all letters, uppercase, lowercase, numbers, characters such as those. So it's hyphen, at, underscore, characters, etc. For other characters that are usually considered sensitive characters, for example, you will use either /p or just prefix it with a slash. Now, you have to be careful there because it also depends on the hex value of the actual character that you're escaping. In my personal experience, it is trial and error when it comes to those characters. Some of them you can safely escape, but if you see that your decoder isn't progressing past that point, then you know you need to add /p and test it again. That's just a little bit of anecdotal experience that I've picked up. There's pretty much a different classification for all of these. So you can specify a lowercase s, which is just a space, or you can just add the space as a text value. Once again, spaces can be encoded in different formats, so you may need to test it with a /s or with just pressing spacebar. Sometimes it is a case of switching it to a /dot because of formatting or encoding that was used, like Unicode, etc. There are special characters that can be used to define the beginning of text that you're looking for and to specify the end of text that you're looking for. This is usually dependent on the type of values that you're trying to extract from the environment, and it is if you have a very long string, for example, and you're only interested in a very small component of that, then you would use those as the start and the end to indicate exactly the data that you want to extract. Characters that you have to escape is a $, parentheses, a backslash, pipe. For those familiar with Linux, if you're not familiar with Linux, pipe is a character that's used quite a bit in Linux to convey outputs from one command to another command, and the bigger than sign. There are some limitations to be considered as far as this goes, but please do read the full documentation at least once, as it will help you to generate these items. So I'll quickly take you through some aspects of working with regex just to show you what to expect. To give you a little bit of a better understanding, I'm just going to slightly move the browser window to a location, and you can now see that I've got regex workbench open. This is just one of the options available to you for regex deconstruction or construction. There are numerous sources online that can facilitate the building, etc. I suggest you play around with a few of them, see which ones you feel comfortable with, that makes logical sense to you. I just like using this one locally on my machine in case the internet's bad or slow or something like that, and in some cases I just work directly on the console of the system because I've got comfortable with the regular expression breakdowns, etc. So you can see I've already pasted a field in here. It's basically the DHCP discover line from the example I showed you in the slides. So let's start with decoding these into a regular expression. So the first three are basically just 3 characters. that can be classified as ASCII. One is uppercase, two are lowercase. So you can see from here that they would be satisfied by the /W. Now you have an option to do /W, which you can see it provides you with a whole bunch of values and matches that it outputs. So you can now choose. You can see these 3 characters, so you can either do it like that, which will show you the values, or you can do W plus, which will also give you those values, or you can do asterisk, and in this case it will fail. So the best option is a plus. So now you've got your April, you've got space, and you've got 2 digits. So if you look at characters, numerical characters, a /D, you go back, you say /D, and you can see that now it's starting to match those. And you can, once again, you can do a plus and a space. So what you've done now is there are 2 regex characters there, and that already matches up to there. And actually it matches up to beyond the space. So now you will see that there is digit digit and then a colon. So a colon falls under /P. So what you can do is /D plus, and you can do a /P. See, now it doesn't match anymore. So now you know that there's a problem with the encoding. So you can do that. It's still not matching, but you can do /D plus again, and you can play around with it to see which options is going to trigger that. If you find that in this case, for example, it's not catching it at all, what you can also do is that. And then what you can do is you can specify the characters that separate there. So you can do that, and you can do that, and you can do that. So you can see it is \dot asterisk, so it is anything to match 0 or 1 times, 0 or more times, and you need to ensure that you split them correctly as well. See, there I've made a mistake. So now my matches don't work anymore. And it is tricky, and you need to figure out how to compensate for that. So you can try a /P and then do it that way. That still doesn't work. You can add that again. So it has a specific problem with the second there. In certain cases, you may not want that information as part of your attributes, so you can capture different information. So you can choose to discard everything up to that point, and I'll show you why in a second. We'll remove that, and then we'll say, okay, I want to match DHCPD, and I want to specify that that's my data. So you can see it's not finding anything there, so you can remove it, and now it finds it again. And this is what I mentioned earlier with you need to specify the start and the end of your data, and you need to test in which scenario it actually provides you with the data that you want and which scenarios it doesn't. The reason for that is because of all the varied formats, encodings, and samples of logs that you can get. So in this case you would go, okay, the next character is a brace, so you can do a /P on there. Okay, so it's not liking that at all, and you can do that, and now it matches again. and you can say that's a number of various items, and you can enclose it again. And you can see now that it's got the whole value there. You can add colon, space, and you can add, that's all uppercase. There's nothing here specific to uppercase, so that's W, and it's a plus. Let's try it. Okay. So it wanted to match 0 or more times. And now it's captured the spaces after that. So we can go back and we can say S. Okay, let's find it. And we can do that. And now it's got DHCP Discover again. Do you see I've replaced the space with /s, a small s, and that way you iterate through everything until you get to your complete result. Okay, so this will give you an indication of how to split your data structures. Now I'm quickly going to take you into an existing DHCP decoder that I've recently written, and I'll explain the logic behind it to you. And it is very important that you get comfortable with reviewing other pre-made decoders or publicly available decoders so that you can see the different methodologies that are applied for extracting data. For example, you can build a single regular expression that will split this entire sequence of text, and it will create the attributes that you want. The other option is you can create multiple smaller regex components, which is the current preferred method for doing so, and you nitpick your little attribute or fields that you want to extract that is valuable to you and your environment and your needs. With that, I'm going to quickly bring in the screen. I'm just going to resize it for you. Okay, so you can see that all the samples are included here. With XML, you can comment by creating a greater than, exclamation, hyphen, hyphen, and then when you're done, hyphen, hyphen, smaller than. Okay. You can see there's various different aspects here. So this is where it becomes important to strip out small pieces of attributes or fields at a time. Because if you can imagine, you write a regex for that string, it's not going to function on the second string or the third string or the fourth string because they're all different. So it is better to look for specific pieces of information. Now if you see at the top here, you can see that the XML was classified as decoder name DHCPD. It looks for the program name DHCPD. So I'll give you an example of why that is the case. So we'll copy that line, and I'm quickly just going to bring in another SSH terminal because I want you to see these side by side. And you can go into var osec bin, you can do osec log test, and you can paste your first string that you've captured from your TCP dumps, and you basically paste it and you see what output it provides. So you can see that this is phase 1 of the decoding, so it's already classified the program name as DHCPD. Now if you see here, program name DHCPD, and I've prefixed it with text start here and text ends there. That's my first phase of recognition done. So it will now know that any events that has that before the syslog facility can actually give you that detail. Actually, sorry, the syslog facility is at the front. But it will look for that from syslogs. And you can see it doesn't matter which one I take. Let's just take that one quickly. It will break it down again. Now, if I didn't have the rules in the decoders already, it would have stopped. Sorry. It would have stopped at this point here. Phase 2 is where the custom decoding comes in. Phase 1 is where the original recognition of the traffic comes into play. So when it comes to items like this, you have to be prepared to change your mindset as to what you think will work and what actually works, and you have to test it, but you have to become comfortable with the regular expressions over a period of time. Now if we scroll down, you can see the first option that I've got. I'll just increase this one again. You'll see these look quite long. So I'm looking for the first field after the program name. And you can see there's a pipe between them. And here is where it gets interesting. There's a balancing and a S/S for pool. So a default space didn't work there. Anything that's found at any of these levels is automatically classified as a field of action because it's an action being performed, and this was retrieved from the original classifications. This can be seen when we look back to our notes. You can see here that action is not classified, so this would be seen as a dynamic field. Just FYI. The next item that would be checked for is if you look at this structure and you look at the regular expressions, you'll see that it is basically any of those characters. So for these are all MAC addresses. Can you see why? If you look at the structure, you'll see that it is 2 characters split by the colon, and then two more characters. So if you count those, you'll see that it is 2, 4, 6, 8, 10, 12. And if you count the W's, you'll see that they make up for those as well, because there'll be 6 of them. 1, 2, 3, 4, 5, 6, separated by that. And the reason for that is the plus. The plus says to match 1 or more times. So that cuts down on the number of times you have to specify /W. You can take it to the next level and take the plus out and do another /W. That'll fix it to a position of 2. So that's a more hard-coded way of doing things. However, if you do a /W plus, if you get it has more leeway. So if the reporting adds a funny character or something like that, you can compensate for it that way. This is currently the expected approach to be taken. And you can see that it will check for different variations of this. You can see there's the pipe, and it will check for all the different positions that the MAC may be in any of these, and it will then extract the data as a MAC address. For the next one, you can see that we are extracting the host name, and how we're discovering that is with this string here. So something I neglected to mention when we started looking at the regex for that. These fields are extracted by the parentheses. So if something already has parentheses around it, you need to escape those and encapsulate the actual text that you're extracting within parentheses again. And this is the data that will be pushed through into that field that you're extracting. Same goes for here. You can see there's parentheses there around it, and those will be action. It doesn't matter if it's finding DHCP discovered, DHCP request, etc. If it finds any of those, it will populate it into the action field. Once you've extracted all of the fields that are important to you, that you want to use, or that you need to keep, you can then move on to the rule sets. So if we pop back, I just quickly want to grab one specifically so that you can see what the output is. Let's take a nice long one. Not that one. Let's take this one. Okay. And we quit. We go back to the other shell and we paste it there. You can see that it takes it. It tells you that it's the DHCP decoder. It tells you what the action is. It's a DHCP request. It tells you which MAC address it came from, the source IP address, and the destination IP address, and the reason, least owned by peer. Your rule applies after phase 2 completion is done. There might be a phase 3 decoder built in depending on the complexity of your decoders, but usually that's limited to phase 2, as you have to do quite a bit of specialized regex to get to a phase 3 decoder. So phase 3 is generally your rule decoding. So if we go back to this and we say var seg rule set rules, you can double tab, it will give you a listing of all that's there. You can say we want to see the DHCPD rules. You can see those are what the rules look like. So your first rule will be a messages grouped. So the reason for that is that any messages that match your default decoders, etc., is at least caught by the system. You will see that's level 3. You would then use the rule ID that was declared for the first match, and you will have a subsequent one with a follow-up rule ID, and that is based then on the regex that you specify or the alternative options that you specify. They don't need to be regex. There's other options available to you as well. Again, I recommend that you go through the documentation. There are many options available. And you can see that each one is built off the previous one. So if SID 110,000, that one is 110,000. If SID 110,001, and it's this one, etc. So these are all, they can build on the previous one, or they can jump back to the parent like this one. And you will then get the description that you can add. As stated previously, you can add text in there that tells you exactly what it's doing. You can add variables in there. For example, any extracted data, any fields you can add in there by simply just go to one. So say for example I wanted to add the action to this. I would simply go $action and close it again. That will automatically insert the field that we extracted out of the data that is named action, and it will insert it into the description. This gets very useful if you want to generate longer messages that are more descriptive in nature. Okay, removing the change, and you can add this up to the end. Something important to bear in mind is the rule IDs. There are prefixed rule IDs that are predefined by Wazuh, that's internal use only. It is important to stay above those levels and choose something that is significantly above those levels and work from that point forward. So what I'll do is I'll quickly show you another decoder. Let's just do this one and show you a 40 gate. So 40 gates is obviously it in this case it's a UTM firewall, so it got quite complex. There are examples. You can see even the rules supplied by Wazuh has example events so that you can run them through the system and test their functionality. And you can see they took the same approach as what I described in the DHCPD. They pulled out specific attributes that they were looking for. So it doesn't matter what your structure is, your complete structure is of the event. This will allow you to extract the specific fields and classify it as an field ID. And you can see the more complex the solution is that sends the event logs, the more complex the extraction becomes. There's firewall version 6 from FortiGate. So to look at the corresponding rule as well, we'll do ls-lh, and we'll check that folder, and we want the FortiGate. So we'll go 1390. It'll help if we 1390. Okay, so here are the rules. You can see that there are rules for specific versions. Remember what I said about grouping messages for a specific type of log that you're receiving? You'll see that this is the case here as well. So they've got different rule IDs, and these are then grouped messages. You will notice here that any messages that match these SIDs or rule ID is then reclassified as 0 so that you don't unnecessarily store information that you'll never use again. There's a level 4. We can go back and look at the classification. So system low priority error. So you can see FortiGate IPsec DPD failed. So that essentially means that your VPN has failed. So it's a low level system error, and you can build classifications around on that, including visualizations, etc. Your important ones that you want to look for in this case specifically is web filter. So you can see that URL blocked by firewall, and you can see that there is a group section below it that was previously in the training discussed. This basically gives you your classification for your compliance aspects and for things that you need to track for your compliance. So when you build your own decoders and rules, you need to make sure, if you have compliance aspects, that you map this out to the controls that you're applying with the rule. So a rule can either be out of need for something specific, like a control, or just in general alert on specific, or either specific or partially specific in situations so that you're aware of it, etc. But it's important to focus on the ultimate requirement for why you need that. Here you can see additional options being specified. You can see there's the rule ID, the level. Then you can also see the frequency, time frame, and how long to ignore it for. So the frequency is how often it can happen within a specific time frame, and if it does, how long you're going to ignore it. There are other options related to this, and it is all covered by the documentation. If you come across a situation where you need to add such quantifiers, please review the documentation. It will be a good guide for you to ensure that you are setting up the rules specifically to your needs. As you can see, there aren't that many rules, but they're the ones that are important for monitoring the environment, etc. You can also see that there is a large number of rules available. You can use any of these as a means to create your own decoder. For example, let's go to the actual folder. We check for, say for example, you want to create something for FTP. So you can look at anything that's FTP. Say for example, you've got Pro FTP, but your version's logging has slightly changed. You can then go into the decoder for the Pro FTP and the rule set for the Pro FTP, and you can make customizations based on the new types of logs you've got by comparing it to the originals that were there. So if we go edit that. You can look at that and you can match it accordingly based on the existing configurations that are there. Anything that's pre-created will give you a good idea of the options available and how to implement them. It will take you a little bit of time to get used to this methodology of working, but it is well worth it in the end, because the regex can be transposed into other areas where you have to process data. It is not specific to event correlation. Regex is used in a lot of financial institutions, websites for classifying data that's being put into text fields, etc. So this is valuable knowledge and experience that you will build up in the long run. Once it is done, everything that you've created, and if it's working, if your log test worked, like I showed you, just to show you again where to find it, it's var osec bin osec log test. You can paste any of your events that you've captured into there, and you can test that your decoders and your rules are working the way that it's supposed to. Once that is done, anything with an alert ID that's higher than 3 and higher will be logged to alerts.log. You can tail that by going tail -f var osec logs alerts.log, and that will show you the alerts that's being processed by the system. So in a case where you've configured syslog ingestion on Wazuh, you can tail that log for it. For those not familiar with Linux, tail means you're following the last 5 lines actively with a -f, which means follow, actively as the log files are updated, and you can filter it for specific items that you're looking for. You can grep for, say, in this case, FortiGate. So I like to use capital ignore, which means that you can just type it in capitalization or not, and the reason for that is the events may not necessarily be capitalized or lowercase. It depends on which way you look at it. And you can then press enter, and it will monitor the log file for alerts that come through that is captured by that specific criteria that you specified. So that's FortiGate. So obviously, if you've created your own decoder, you would specify your decoder's name or your rule names or something that is unique to your rule that you can capture that's being logged to the alerts log. Once you're done, Control C, and it clears that out for you. Clear your screen, just type clear and enter. That brings us to the end of this training session. Just to recap, we've covered what decoders are, their purpose, their outputs, what rules are, their purpose and their outputs. I've shown you the structures, the regular expressions, the attribute classifications or the field names. These are quite important. Be comfortable with them. If you need to print out a little cheat card that you keep on your desk, especially if you're going to be creating lots of decoders and rules. And I've also shown you what the data looks like, how to identify the fields that you're interested in, and how to pull them out. By all means, do play with the system. See if you've got custom logs that aren't currently able to ingest, if you can build logs, even if they're not pertinent to your environment. Practice does make perfect when it comes to regex. I hope you enjoyed this session, and I hope you enjoy creating your own regex, and I will see you in the next training.